Yes. Yeah. Yeah. Good evening, all. Right. So we had a session right previously. Right. I was just briefing you about what is big data, why Hadoop and Spark, drawbacks with the current databases, advantage of Hadoop and Spark, right? The Hadoop and Spark job market, right? Impacts. So here Hadoop is meant for two things. Hadoop is meant for both storage and for processing. Hadoop is meant for storing as well as processing. Any technology performs storage or processing, but Hadoop performs both storage and processing. For storage, does it use any database? No, databases has got some drawbacks. Despite of those drawbacks, still Hadoop doesn't go with databases. It is going with a kind of file system called Hadoop distributed file system. For processing, MapReduce or Spark. Hadoop is meant for batch applications. Hadoop is not for online applications. Online applications means user interactive application. User gives the input, but in batch applications, user doesn't give any input. User non-interactive applications. Credit card statements for millions of customers. Example, right? Generating credit card statements for millions of customers here, user input is nowhere required. But if it booking a movie ticket, user input is required. Making an online transaction, user input is required, right? I was talking about in the previously I was talking about drawbacks with the current databases. Most of the databases are limited storage, no parallel processing. If volume increases, speed decreases. The volume of the data is increasing. Total amount from sales 1, total amount from sales 2, total amount from sales 3. 10 records, 10 lakh records, 10 crore records. Record to record, right? If the volume increasing, if the volume is increasing, speed decreasing, right? Yes. Even if complexity increases, the speed decreases, right? Even if complexity increases, speed decreases. Total amount, the average amount, standard deviation of amount. Here, average amount takes more time, right? As compared with the sum. First sum to be calculated, next average has to be computed. As compared to this, average amount takes more time. Standard deviation of amount. Standard deviation of amount, right? Lot of internal processing is required. Lot of internal processing is required. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. So these are the major drawbacks, right? With the databases. We've come to this Hadoop advantages, right? Hadoop advantages. Unlimited data storage. Unlimited data can be stored. Unlimited data storage. Horizontally unlimited number of unlimited slaves. Very high speed processing because of parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured. This was normalizing commodity. Not on all, it doesn't mean it should have highly configured, right? It can run an initial configuration. Databases like Oracle can support unlimited storage. Even database can go with multiple systems or multiple slaves of databases, max limit on number of slaves. Oracle can go to maximum 56 nodes for storing its data. MySQL 54, MySQL 256, SQL Server 256, DB to 256. Data can go with the maximum 512 nodes. Teradata, Netija, and Vodka. They're used for data warehouse, right? Specialized data is used for the warehouse for So all these three items, but these two Teradata and Etidata they are going with 1024 nodes for storing its data. So here, but there is no limit on the number of slaves that Hadoop can have. Yahoo when first time implemented Hadoop went with 4,000 for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. Systems, nodes means systems. Facebook when first time implemented Hadoop. Facebook when time implemented Hadoop went with 8,000 nodes for storing its data. Currently, Facebook going with 50,000 nodes for storing its data. So if you see the speed, if you see the speeding, this is what Hadoop is prevent storage point of view and even processing point of view. Yahoo has taken a table to check speed of different databases. Has taken a table of 100 TB consisting of 1,024 columns. Task sorting based on 16 columns. Time taken, right? Oracle has taken nearly 3.5 days to process. MySQL, right? It's taken nearly 6 days. Teradata 4.5 hours. That is Hadoop 3.4 minutes. Latest version of Hadoop has taken 1.2 minutes. Okay, so these have taken days of time. These have taken hours of time, but Hadoop has taken minutes of time. But even Hadoop has very high speed, right? Hadoop has got very high speed. But Spark is 100 times faster than Hadoop. Spark is 100 times faster than Hadoop. See the speed of Spark. Already Hadoop has got very high speed where it has taken only minutes of time. But Spark is 100 times faster. So very high speed process, both Hadoop and Spark commonly used together, right? Yes. So now, how exactly data load? See how exactly. See, before that, I was discussing about architecture, right? Yes. Hadoop was just talking about. Hadoop doesn't follow client server. Hadoop doesn't follow client server architecture. It doesn't follow client server architecture. Hadoop follows master slave architecture. It follows master slave architecture. It follows master slave. Single master, multiple slaves architecture. Hadoop cluster means group of nodes, group of nodes, group of nodes means systems connected in a network, connected in a network. Hadoop cluster means group of nodes, systems connected in a network. There are two types of nodes: master node, slave node. There are two types of nodes: master and slave node. Master node is a name node. Slave node in Hadoop terminology like a data node. Master node responsibilities, yes, task assignment, load balancing, assigning tasks to the slave systems. The task should be equally given to all the slaves. If fault tolerance, if any system multiple tasks are executed in systems parallel, if any one slave, if any one slave fails, then task of it has been to any of the slaves. Health monitoring. Health monitoring, right? Yes. Okay. Slave node responsibilities: storing the data and processing the data. Slave node, okay, just observe this diagram. Hadoop master and slave. Same multiple steps. S1, S2, S3 up to Sn. So this is master. This is master. That's slave. Master node. This is slave node. Slave nodes we call it as data nodes. Within the steps, data process steps. Means you talk about any f1.txt. This we call it as a cluster. Group of systems connected in a network. Group of systems connected in a network. Master node, slave node. Group of network. One is master, remaining all are slaves or data nodes. So you have got a file f1.txt. We have got f1.txt. For example, each system capacity 1 TB, 1 TB, 1 TB. The size is 2 TB. It cannot fit into any of the slave systems. It has to be divided into smaller parts and has to be distributed across multiple systems. The advantage we see is distributed. Data is distributed across multiple systems. Data is processed by multiple systems. Data stored across multiple systems. Data processed by multiple systems parallelly. Data stored across multiple systems and data processed by multiple systems parallelly. Distribution and processing. Right. How exactly the data stored and processed, right? The data is processed in Hadoop. In Hadoop, data in the form of data is in the form of files. In Hadoop, data is stored in the form of files. Each file in each file in subdivided into subdivided is again subdivided into blocks. File is again subdivided into blocks. Blocks are distributed. Save nodes and are processed. And are processed. Blocks are distributed across multiple slave nodes and are processed. Default block size. Default block size 60. Latest versions. In latest versions, it is 128 MB. Default block size 64 MB. Versions it is 128 MB. For example, F1.txt. About F1.txt. Size is 200 MB. F1.txt size is 200 MB. As it is some banking data. It has got some banking data. Default block size. Default block size. Assume default block size 64 MB. Default block size 64 MB. Number of blocks. In how many blocks? Number of blocks. File size by default block. File size default blocks. So the f1.txt size is very, it has got bank data, right? Default 64 number of blocks. File size by default block size. File size is what? 200. 200 by 200 by 64 means like approximately, right, 4 blocks. Approximately 4 blocks. B1, B2, 64, 192 you will get. Fourth block, fourth has 8 M. B2, B1, B2, observe here, B3, B4. B1 block, B1 block, B1 block has 64, B1 block 64 MB, B2 block also like 64 MB, B block also 64 MB is 2, and B4 also 64 MB. Sorry, in B4 8 MB only. 8 MB only. 64 means 190 MB in the means 56 MB free here. 6 MB free. I got same thing I'll copy. There's one more file. Assume size 190. Assume that you got telegram. D blocks, number of blocks 3 blocks. So here B5 B5 has 64 numbers. So these are stored in system. This in system 3. B56 that's storing 64 MB, 64 MB, 64. 64 MB in this, 64 MB in this, 64 MB in this. For yes, here my query is 56 MB is free here. Why this B5 56 MB is 26 MB, why I can't print B4? Retrieve.txt. Retrieve.txt means combining this B1 plus B2 plus B3 plus B4. B1 plus B2 block plus B3 plus B4. F1 data, assume that B5 data stored in B4. Assume if data stored B4. B4, 64, 64, 64, 8 plus MB plus MB. 32 root 6. Root 6 is what actual file size is 200 MB. Wrong computation. Reviewed. When we reviewed f1.txt, when we reviewed f1.txt, this to that's with respect to HDFS blocks, HDFS blocks. That's with respect to HDFS blocks. Every file should have dedicated number of blocks. Dedicated number of blocks. Every file should have dedicated number of blocks. In file have one blocks, a file should have one blocks in block in a single block. No file in a single block. Right? In a single block, no files that will every file have dedicated blocks in a single block. In a single block, no file data to be stored. Every block should have every block will have value. Every block will have equal values. It's the last block. The last. Every file should have a number of blocks. Single or no two file data will store. Every block have equal value. The last block. Except the last block means everywhere every have equal value. Which block will have less. Configuring block size. Configure block size. Configuring means increasing accuracy. Increasing of in the block size. Go to the install directory. Go to the Hadoop install directory. Yeah. HDC1 file name. HDFS-site.xml. One file will see it's an empty file. Open file. It's an empty file. Open file and configure the following. Default. Hadoop install. That will see open file and configure the file. It's an empty file. So just XML means your own tags. Configuration. Opening is open. Status close slash configure. This will close in configuration. In that property and slash property. In this property name block.size slash name value for this. Default is 184 MB 64. By default not specifying anything. Just want to get you want to keep 50 MB. Here's my default says MB 50 MB 30 MB whatever you want. You can your file will be divided into this fixed size. Each size will be 50 MB. For example, your 1 GB file like 1000 MB file 1024. If you take 100 blocks In this way, you can also set your own block. I'm going to discuss four here. Just observe here. I'm going to discuss four cases.
Usually, if we play the decentralized one hybrid, increasing the data rate. If we play, for example, 1 is 200 MB like that, so we can increase also your rate. Less blocks means you will fast fetching anything difference will come.
Yeah, yes, I was just about to ask the same query. So the same query.
Okay.
Which is advantageous? Having a bigger block size, smaller, smaller default block size. I don't know for your knowledge. Which is advantageous? I'm saying you can set your own block size. Just think bigger, not small.
Sir, it depends on data, right, sir? So if you have data, split it, right? So based on that smaller,
Okay. Observe this. Example, I got f1.txt, f1.txt, 1000. I'm taking default block size. Default block size taken as 500 MB. 500 MB.
2 blocks we can split.
2 blocks. Is it advantageous? If you have 40 nodes in that, data is stored in only 2 nodes, and data processed by nodes only. Data processed by nodes only. But if it was default block size, at least around 10 systems should be running parallelly. Right? So lesser speed means, example, you brought for building construction, you brought 40 labors. In that, you are giving work to only 2 labors. Remaining 38 labors are free, right? If you give that work to all labors, you should have high speed, right? So got high speed. So that means if you are taking like bigger default block size, data won't be distributed on all that systems. Only less number of systems the data gets distributed, only less number of slaves will be, yes, running parallelly. You won't achieve that much of speed, right? Yes. And what happens if I take less block size? Is it advantageous? Hmm. Okay. For example, this example to f2.txt unknown default access the name number of loss is advantage is advantage. Already the very already is a very small and again given into smaller parts, dividing into smaller parts, distributing across multiple systems, and then combining that. And later combining this, and later combining the result and taking process. So the block size should not be big or small. So the block size should not be too big or too small. That's the result. Hadoop has given default block size 1 MB. Okay, depending as right, depending on the data also increase or decrease. Depending upon your class capacity, depending upon the unit, you can also decrease or increase based on that. What speed you are expecting. You cannot much or much. Now understand this is what default block size we can configure. I'm saying yes. Now I'm going to discuss 4 cases, right?
Just a small doubt here. If your file size is less than block size means how that scenario means?
I'm going to say
Okay. Based on that conversation I got doubt on that. That's
so,
interesting.
yeah. What is the case? 3 cases. Case 1. Case number of equal to number of slaves. What was yours? If the block size
No, the block size default 128 MB. So the file have with the block size, how it divided into the blocks like that. Like it did go to the first block only, or it will also divide
only one block. If
one
it
block. Yeah,
has got 64 MB, if it has got 8 MB, the 8 MB will be storing, but remain
yeah, that only so.
if number of blocks equal to number of slaves. For example, think that you got 4 blocks, you got 4 slave systems. Number of blocks means B1, B2, B3, B4, B4. You got 4 blocks. Slaves like S1, S2, S3, S4. How exactly the data storage and processed you can see here. How exactly data stored and processed Hadoop.
Sir, I have a small. Sir, each the data, it's fully loaded or somebody kept.
Each block, once again,
We have 64 MB data, so it's 64 MB storage. So 100 MB enter into the one. Is it fully loaded 61 MB or something? Some storage will be kept like.
see very simple, right? Okay. You got 10 blocks are there. 10 blocks are there. 64 MB. Assume that your file is divided into 10 blocks,
Okay.
4 MB blocks, f1.txt. f1.txt, right? 10 blocks. Your systems, 5 systems are there.
Yes.
5, 1, 3 in systems are there. The system 2, system 3, system 4, system 4, system 5. But 10 blocks are, how these 10 blocks are going to be stored into this? 5 systems. First, B1, B2, B1, B2, B3, B4, B5. Again, B6, B7, B8, B9, B10. Means each system storing 2 blocks. Each system will have equal one. Only that B10 will have the less one. Anytime you see whatever the file says, only the last block will have that less. B1, B2, but if you got only 2 systems in S1 5 blocks, in S2 5 blocks, means all will have equal volume except the last one will have less value. So depends on number of these blocks are distributed. Our file size, your work is what just the blocks automatically it is going to by it. Means it's going to divide into blocks and the block is going to distribute multiple systems. But everything taken care by the framework itself. So what are the size divided and stored across it? Because you have will be maintaining a cluster with more systems. So they distribute it. But okay, the difference in the speed we observe. What I'm going to discuss in that next discussion. If the number of blocks equal to number of very high speed you see, very high speed. For example, FMC size 30 MB. Assume the block size 64 MB. Number of blocks how many? 30 by 64. 4 blocks. How these 4 blocks? 4 like B1, B2, 3, B1, B2, B3, B4. How these 4 blocks process? 4 things that is of 10 lakh records, 10 lakh records, 10 lakh this before 5 lakh records. How these blocks are for small systems? This is the this one. How many slaves? 4 slaves. 4 slaves. This one 4 slaves. S1, S2, S4. So B1, B2, so they are distributed. Data is divided. These blocks are stored on multiple systems. Yes. This is the master node. These are data nodes, slave nodes, slave test data nodes. Within the master node, we say the node. We have got node. Name metadata means about data. It won't store the data, but data about data. Data about data. Not into how many blocks? B2, B3, B4. Where B1 is in S1, where B2 in S2, where B4 in S4. This information will be this node. Data. This is how the data is stored. Now data processing we observe. Data processing. Now we process F1 65. Always a job divided task. Job into task. Job divided into task. Number of tasks equal to number of unique blocks. Number of unique blocks. Number of unique blocks how many? 4 blocks. Blocks means 4 tasks. 4 tasks. Jump process for TXT. Yes. How many tasks? T1, T2, T3, T4. T1 task what? For executing B 10 lakh reports. T2 task is executing T is for B3. T4 is B1. Execute one just to execute the T1 task as B1 is present as 1. S4 only execute. Who should execute this T2 task? Which system has to execute? The T2 task becomes executing B2 present is S1 only should execute. No tasks. S1, S2, S3 is more. Means here 4 tasks means 1, T2, T3, T4 are executed by 4 slaves. 4 slaves. S1, S3, S4 parallelly. No task is all executed parallelly. Right? That's very high. Very high. No, none of the tasks is in the waiting. But if you observe this case too, some tasks will be in the waiting state. That's right. Case if you observe blocks. Blocks are less. In this case, less speed. Less speed. How 4 blocks slaves are B1, B2, B3, B4. How many slaves? 2 slaves. S1, S2. F1 dot F1 dot 230 default block size. Assume 64 MB. Number of 264 blocks. Means B1, B2, B3, B4. how this 4 blocks process, just 2 slaves only, less slaves. How this data is distributed, this will is master within the B1, here B2, again B3, B4. Yes. This one, this S2. Here S1 dot txt divided into 4 blocks, B1, B2, B3, B4. Where this within this master node we say we got a name metadata, metadata about data. B1 by S1 by S2. B3 again S1, B4 again S2. This is how the data is distributed across multiple systems. That is fine. But if you talk about data processing, right? It's about a job to process f.txt, job to process 1.txt divide tasks. Number of tasks depends on number of unique blocks. How many unique blocks here? By using, let's say, here 4 blocks, right? 4 blocks means number of tasks equal to 4 tasks. 4 tasks. Job to process 1.txt divided into 4 tasks. T1, T2, T3,